Okay, class, today we're in section 6.4. Solve linear systems by multiplying first. Before, you solved linear systems by adding or subtracting. Now you will solve linear systems by multiplying first. Why? So you can solve a problem about preparing food, as in exercise 39. Key vocabulary: least common multiple. In a linear system, like the one below, neither variable can be eliminated by adding or subtracting the equations. For systems like these, you can multiply one or both of the equations by a constant so that adding or subtracting the equations will eliminate one variable. 5x plus 2y is equal to 16. 5x plus 2y is equal to 16. 3x minus 4y is equal to 20. If you notice, if we try to add or subtract going down, neither the x will disappear nor will the y. However, if we multiply the top equation by 2, we will end up with 2 times 5x, that will give us 10x. 2 times 2y is equal to 4y. And 2 times 16 will give us 32. Now when we look at the system, especially after we rewrite what we have in the bottom, which is the same. 3x minus 4y is equal to 20. 3x minus 4y is equal to 20. Now, if we try to add going down, you should notice that the y's will disappear. The y's will end up canceling out. Even though we multiply it by 2 here, the new system is equivalent to the original system. Example 1. Multiply one equation, then add. Solve the linear system 6x plus 5y is equal to 19 and 2x plus 3y is equal to 5. Solution. Step 1. Multiply equation 2 by a negative 3 so that the coefficients are opposites. So here's our original equation, 6x plus 5y is equal to 19. And then we got 2x plus 3y is equal to 5. Now we're going to multiply the bottom equation here by a negative 3. Why? Because when I multiply here by a negative 3, this will become a negative 6, and the 6's will end up canceling out, as shown over here. So negative 3 times 2x is equal to a negative 6x. Negative 3 times the 3y is equal to a negative 9y. Negative 3 times 5 is equal to a negative 15. Now when we add going down, we get 6x minus 6, that's gone. Positive 5y, when added to a negative 9y, is equal to a negative 4y. And then 19 minus 15 is equal to 4. Now we're going to divide both sides by a negative 4. Negative 4 here and negative 4 there. A negative 4 divided by a negative 4 is equal to a positive 1. So we got 1y is equal to 4 divided by a negative 4 is a negative 1. Step 4. Substitute negative 1 for y in either of the original equations above. So it doesn't matter which one you pick. And the general rule is you try to pick the easiest. So here they pick 2x plus 3y is equal to 5. So we got 2x plus 3 times a negative 1 because y was determined to be a negative 1, and that's equal to 5. 3 times a negative 1 is negative 3. 2x plus negative 3 is equal to 5. So now we're trying to solve for x. So keep it in mind, we're trying to get x by itself. We want this to be by itself. That means we got to get rid of that negative 3. So below it, I must put a positive 3 and a positive 3. A positive 3 when combined with a negative 3 goes to 0. 5 plus 3 is 8. I'm left with 2x by itself. So now I have 2x is equal to 8. Next step, divide each side by 2. And when I do that, 2 divided by 2 is 1, so I'm left with 1x. and then 8 divided by 2 is 4. So x is equal to 4. So the solution to our system is 4, -1. Okay, next we're going to deal with multiplying both equations. To eliminate one variable when adding or subtracting equations in a linear system, you may need to multiply both equations by constants. Use the least common multiple of the coefficients of one of the variables to determine the constants. In this system, we're working with the equations 2x minus 9y is equal to 1. Also, 7x minus 12y is equal to 23. Here, we multiply the top equation by 4 and the bottom equation by 3 because we're asking ourselves what number is it that 9 and 12 can go into evenly, the lowest number. And that number would be 36. Now notice what happens. 4 times 2x is equal to 8x. 4 times a -9 is equal to a -36y. That should have been a -9y. 4 times 4 is equal to 4. 3 times 7x is 21x. 3 times a -12y is equal to a -36y. And then 3 times 23 is equal to 69. Notice the y's are now have the same value. And when we go through to subtract, they will disappear. Okay, now the reason why they're going to disappear is because on the bottom you're going to subtract. That's equivalent to applying a -1 throughout the bottom. So everything will become the opposite. So a positive 21x will become a -21x. A -36y will become a positive 36y because a negative times a negative is a positive. And then a positive 69 will become a -69. Now notice what happens. The y's will cancel out. -36y and a positive 36y will cancel. Now an easier way to do this, at least to me, would be to multiply the bottom equation by -3 in the first place. Alright, so if I did that, see, -3 times 7x would give me that -21x. -3 times a -12y would give me a positive 36y. And then -3 times 23 would have given me that -69. But either way is okay, whatever you're comfortable with. Example 2, multiply both equations, then subtract. Or multiply the bottom equation by a negative value. Solve the linear system 4x plus 5y is equal to 35. And 2y is equal to 3x minus 9. Solution. Step 1. Arrange the equations so that the like terms are in columns. Notice here, they're not aligned the same way. So we're going to arrange everything how it is in the top equation. That is, x is first, y is second, and the constant is last. So once we do that, we end up with 4x plus 5y is equal to 35. That's the top equation. And for the bottom equation, we will end up with a -3x plus 2y is equal to 9. Once again, this is one of those things that you should already know. But as a repeat, 2y is equal to 3x minus 9. That's this equation. All right? I want the x and the y on the same side. The y is already over there, so I must move the x. So to do that, I'm going to say minus 3x minus 3x. Positive 3x when combined with a -3x, it's gone. -9 is by itself. I realize that I cannot add or subtract 2y and 3x, so all I can do is represent. Since we're writing the x first, we're going to put the x first down here. -3x plus 2y is equal to a -9. That's what they have there. There to there. Step 2. Multiply equation 1 by 2 and equation 2 by 5 so that the coefficient of y in each equation is the least common multiple of 5 and 2, which is 10. So multiplying the top equation by 2, you end up with 2 times 4x, which is 8x, 2 times 5y, which is 10y, and then 2 times 35, which is 70. But instead of multiplying by 5, we're going to multiply by negative 5. We're going to do 2 steps in one here. I'll explain in a few seconds. So we're going to multiply here by negative 5. So negative 5 times a negative 3x will give you a positive 15x. Negative 5 times a positive 2y will give you a negative 10y. And then a negative 5 times a negative 9 will give you a positive 45. Now all you have to do is just add going down. So when you do, you get 8x plus 15x, that's 23x. The y's are going to cancel, and you'll end up with 115. 70 plus 45 is 115. When you solve for x by dividing both sides by 23, you end up with x is equal to 5. Now, the advantage to multiplying through by that negative 5 is that you don't have to remember to subtract when you're adding going down. See, here, most of us will make a mistake and forget to change each sign to its opposite. By multiplying by the negative, that's already done for us. So we won't make a mistake and say 10y plus 10y is 20y, or come out right here with a negative 7, okay? Or come out this right here with 35. But anyway, once we solve and we find that x is equal to 5, now we take either equation and plug 5 into the equation. After doing so, we get 4x plus 5y is equal to 35. Replace the 4 with the 5. Replace the x with the 5. So 4 times 5 is 20, plus 5y is equal to 35. Minus 20, minus 20. That'll leave us with 15. And then divide both sides by 5, and y is equal to 3. Example 3, standardized task practice. Darlene is making a quilt that has an alternating stripe of regular quilting fabric and sateen fabric. She spends $76 on a total of 16 yards of 2 fabrics at a fabric store. Which systems of equations can be used to find the amount x in yards of regular quilting fabric and the amount y in yards of sateen fabric she purchased? Sateen fabric costs $6 per yard. The regular quilting fabric costs $4 per yard. These are our choices. X plus y is equal to 16. X plus y is equal to 76. B. X plus y is equal to 16. 4x plus 6y is equal to 76. C. X plus y is equal to 76. 4x plus 6y is equal to 16. And then D. X plus y is equal to 16. And 6x plus 4y is equal to 76. You can eliminate choice A because x plus y cannot equal both 16 and 76. Solution. Write a system of equations where x is the number of yards of regular quilting fabric purchased and y is the number of yards of sateen fabric purchased. Equation 1, amount of fabric. Amount of quilting fabric, x. Amount of sateen fabric, y. Total yards of fabric, 16. Equation x plus y is equal to 16. Equation 2, cost of fabric. Quilting fabric price, 4. Amount of quilting fabric, x. Sateen fabric price, 6. Amount of sateen fabric, y. Total cost, $76. Notice here is quantity and here is price. The system of equations is x plus y is equal to 16 and 4x plus 6y is equal to 76. So the correct answer choice is B.